Okay. So as you know that your attendance are taken from last week, so beware of that. Okay. Now last day I have told you about the different methods to soften hard water. One was the permuted method, that is ion exchange method, and another one was sodium carbonate method, that is washing soda method. What is this was to remove the permanent hardness. So how many types of hardness is there? You can tell it easily. How many types of hardness is there for water? Yes, hardness of water and its removal. I have started this portion. Temporary hardness. Yes, and permanent. Now temporary hardness, the method was boiling, and another one is reaction with calcium hydroxide or slake lime. Two methods was there. One is boiling and another one is reaction with slake lime, and then filter, boiling and then filter. Permanent method, that is reaction with washing soda. Second method was by ion exchange method, and one method is there, that is calgon. So for the removal of permanent hardness there is three methods. One is reaction with washing soda, then ion exchange method, and then calgon method. Okay. So this portion was already completed, reaction with washing soda, and I am discussing on the ion exchange process of removal of hardness. So in ion exchange method, I have told you in the last day about two methods. One is permuted method, that is inorganic ion exchanger, ion exchange, that is inorganic ion exchanger, or permuted method, and another one is organic ion exchanger, which is synthetic resin. Now resin is a solid substances which may be synthetically formed, or sometimes it is formed from the plant origin also. It is a hard substances. Okay. Now when it is synthetically born or synthetically prepared, it having some special characteristics. Okay. So last day I have told you about permuted. What is permuted? It is symbolically represented as Na2Z. Z is a large molecular mass, and when the calcium or magnesium ion come in contact with these substances, that is permuted, then it exchange the sodium with the calcium, and the quality of the hard water is changes to soft water. It was the ion exchange method, that is inorganic ion exchanger, that is permuted method. Now today I will discuss about what is synthetic resin method. Okay. So resin is also called organic ion exchanger. Now I have just follow the previous one, the inorganic ion exchanger. Here only the cations is substituted, the cation part, that is calcium or magnesium is substituted, but in organic ion exchanger or in resin method, there are two types of resin is there, one is cationic exchanger and another one is anionic exchanger. Okay. Now, cationic exchanger, this is called H plus resin, and anionic exchanger is called OH minus resin. So, organic ion exchanger is of two types, one is cationic, that is H plus resin, and another one is anionic. You cannot see the lower half. Okay. So, organic ion exchanger or resin, one is cationic or H plus resin, another one is anionic OH minus resin. Okay. Yes, permutate is some type of short than that of the zeolite. Zeolite, the Z part is called the zeolite. Na2Z, it is the aluminosilicate. This part is Z, and when Na is here, then it is called the permutate. This part is called the zeolite. This part is called zeolite, that is aluminosilicate. When it becomes sodium aluminosilicate, then it becomes the permutate, but this part, that is aluminosilicate with water molecules, is called the zeolite. Okay. So, these cationic resin and anionic resin. Now, last day I have drawn the pictures how the exchanger, that the exchange process is take place. For this process also, that is when resin is applied, then here at a time two types of resin is there in two different compartments. I am drawing the picture of the resin method. Okay. Now, in one compartment, here is the hard water input, there is the resin, and then the pebbles, and from that no. Another compartment is there which is packed up with the anionic ion exchanger, This part is the resin and this part is the pebbles. This is packed up with anionic exchanger, and this one is with cationic exchanger. Now, what is the chemistry behind that? Now, when a water sample contains calcium or magnesium for the hard water, then for cationic exchanger, not only for the cationic species, but also for the anionic species, that is Cl minus, SO4 minus, 2 minus, these also we have to replace to make the pure water, or this is called the demineralized water. Okay. Now, demineralized water, when they are free from the cationic species and also from the anionic species. Now, just follow the chemistry of that. So, when we this is the hard water. So, first case, in the first compartment what happens, here it is packed with cationic exchanger. So, the cationic part, that is Ca2 plus or Mg2 plus, it will be replaced by H plus. It will be replaced by H plus, and in the second case the Cl minus or SO4 2 minus, it will be replaced by OH minus. Okay. So, this is the role of the cationic and anionic exchanger. So, in the first compartment the cationics are eliminated, in the second compartment the anions are eliminated, and when we get the water, that is at last this point, it is soft water, and it is also called demineralized water. Demineralized water, because it is free from all kinds of cation or anionic species. Okay. So, this is the synthetic resin method of preparation of soft water from hard water. Okay. Now, we have to see the reactions involved in between this very simple reaction, that is, suppose a salt, that is calcium chloride is there. If a salt, that is calcium chloride is there. So, just first one, in the first case what will happen? Suppose a salt is calcium chloride, it is a hard water containing salt. Now, when calcium, it is charged with the first compartment, then the calcium is replaced by H plus, and the reaction is calcium 2 plus plus 2 Cl minus plus H plus resin, calcium chloride and H plus resin forming calcium resin. It forms calcium resin, and another one, that is H plus and Cl minus. It is the first half. Okay. And if magnesium is present, that is magnesium chloride, then also, or magnesium sulphate, then the magnesium 2 plus, I am writing the equation here, magnesium 2 plus plus SO4 2 minus plus H plus resin. Then what happened? It will produce magnesium resin complex plus H plus plus SO4 double minus. It is the reactions of the first compartment. Okay. Now, come to the next one. So, when next one, that is Cl minus, suppose for this one, when I am rubbing this portion, when Cl minus, this Cl minus, it works with OH minus resin, then the OH minus ion will be free and Cl resin will be the complex, because OH minus was monovalent anion, Cl also a monovalent anion. So, this is the next compound formed when in the anionic compartment. If sulphate is there, then it also will form the sulphate anion and 2 OH minus, SO4 2 minus plus OH minus resin. Here also it will form the 2 OH minus, OH minus resin, OH minus plus SO4 2 minus resin complex. So, just follow that in the first compartment the cationic exchanger, it replaces magnesium or calcium and give H plus to the solution, and in the second case the Cl minus or sulphate is replaced by the OH minus in the, and ultimately when H plus coming from the first compartment when it adds to the next compartment. Here the presence of OH minus is there. So, here H plus and OH minus combine together to form the water, and for this reason the reaction, that is the ultimate product, is called the demineralized water, because it is free from all kinds of minerals. Okay, because calcium, magnesium, these are minerals, we know it. So, this is the ion exchange method by organic ion exchanger or synthetic resin method. This is called synthetic resin. Now, here also in the last day I have told you about the regeneration of the permutate. Okay. Now, as the limited amount of substances are taken in the compartment and every time it is the exchanging, then at the time the H plus ion is replaced by the calcium or magnesium, and calcium resin, and you can see in the reaction there is magnesium resin, calcium resin, here also chlorine resin, sulphate resin are formed. When total H plus ion is replaced, then the activity of the resin are lost, and for this reason there are two solutions are used. In the first compartment, dilute HCl solution which charges the H plus resin, and in the second compartment a weak solution of sodium hydroxide is used. Generally a 10% solution of sodium hydroxide is used to recharge the resin. Okay. So, this is the regeneration of the potential or activity of the resin. How can we do it? By using two solution, and for this reason the compartment there is the, in the first compartment there is a tube from where the HCl is passed through the zeolite, the resin, and in the second compartment here also one tube by which NaOH, aqueous solution of NaOH is passed through the resin, so that it can charge again. So, at that time when the activity of the permutate is lost, the resin is lost, then we have to stop the input of hard water, then we have to charge it, and there is a scheduled time, at the scheduled time when we have to recharge it. Okay. So, this is about the synthetic resin method. Any problem up to this? I have to repeat it once. May it requires the repetition because this part is very important. So, from preliminary, that is temporary hardness and permanent hardness. Temporary hardness very basic, permanent hardness, that is washing soda method and the permutate method. Okay. Permutate method. Okay. So, if I have to repeat, so I am repeating from the permanent hardness. Okay. So, permanent hardness, it is due to the presence of salt of calcium, magnesium with chlorine and sulphate. These are generally present in any water sample, then it is called a permanent hardness. Okay. Now, first one method, removal of permanent hardness. One is washing soda method, washing soda, that is sodium carbonate. Number 2 is permutate method or ion exchange method. Now, in ion exchange method there are two parts. One is inorganic ion exchanger, inorganic, which is called permutate, and another one is organic ion exchanger, which is called as resin. And another one method was there, which is known as Calgon method. Number 3, Calgon method. Calgon is also a compound of sodium phosphate, calcium phosphate, later on it will be discussed. So, first complete this. So, first one, that is washing soda method. So, suppose calcium chloride is present. Up to this clear? This is the processes by which we can remove permanent hardness. Okay. Now, start one by one. Washing soda method. Suppose calcium chloride is present. Okay. Now, we add sodium carbonate. Now, there is a very simple reaction will be there. Okay. Now, very simple reaction, that is formation of twice of NaCl plus calcium carbonate. I have told you earlier that calcium carbonate is insoluble. It is insoluble. So, it can be precipitate out, that is if we precipitate, if we filter, then calcium carbonate will be separated. So, in the solution it is sodium chloride. Okay. Now, it is the removal of calcium chloride. Suppose magnesium sulphate is there, then Na2CO3, it will produce sodium sulphate and magnesium carbonate. Again magnesium carbonate can be separable by filtration. So, this is the washing soda method. Okay. Next one coming to the, clear up to this? Next one coming to the ion exchange method. So, from the term ion exchange, that there the ion which is present in the water sample, that is responsible for the hardness of the water. Okay. So, which was responsible for the hardness of the water will be exchanged. Now, the exchange cation is the, we should exchange the cations which is not harmful to us. Okay. So, in that place we have to take the sodium or potassium etc., which is not harmful to the human being. Okay. So, first method is that ion exchange, one is inorganic ion exchanger. Inorganic ion exchanger, which is simply called permuted method, and another one is organic ion exchanger, which is called resin. Now, what is permuted? Permuted is Na2Al2Si2O8 XH2O, and it is simply called Na2Z. Z, it is that part. Okay. So, this permuted and this part is called the zeolite. Okay. Now, when a permuted process is applied, that is, then this compound reacts with the calcium or magnesium. So, the sodium is replaced, that is calcium or magnesium is replaced by sodium. So, by this way, that is exchanging of the cations, we can remove the hardness. It is the removal by ion exchanger or the ion exchange resin. Another one, that is organic ion exchanger, it is synthetic resin method. The synthetic resin method here, as here you can see the sodium ion is present, but in the resin here H plus ion will be present, and the resin is also divided into two parts. One is cationic exchanger, because calcium magnesium is present with one anion, and maybe the anion is hard in nature, because chlorine and sulfate is there, it is hard in nature. So, cationic exchanger and anionic exchanger. Now, the cationic exchanger contains H plus in its structure in place of just assume as in place of sodium, and in anionic exchanger it contains OH minus. It is generally the salt of the carboxylic, long chain carboxylic or sulfonic acid. Okay. So, these are the exchanged by the calcium or magnesium, and I have drawn the picture. You have seen the picture how the hardness is removed. Okay. Now, what is the reaction? Suppose a salt contains magnesium. Suppose magnesium sulfate we have to remove by the permuted, that is the resin method. Then just dissociate it, Mg2 plus SO4 2 minus. This is done by cationic exchanger. So, reacts with H plus resin. So, it will produce H plus magnesium resin. Sulfate, here we have to react with OH minus resin, then it will produce the OH minus plus SO4 2 minus resin. Okay, so SO4 2 minus and Mg2 plus are blocked by resin, and H plus and OH minus is freed up. So, when H plus is coming from the first compartment mixed with the in the second compartment, it produces the water again. Okay. So, in this way we can remove the permanent hardness. Clear up? Clear? And last I have told you about what is the regeneration of resin. Okay. That how we can regenerate the potential of resin. Next day I will tell you about the Calgon method. Okay. So, now I have to take your attendance. Okay. Angona Banerjee. Diti Priya was present last day. Jasmine. Jhilam. Okay. So, next day I have told you about the next part, that is Calgon method, separation of permanent hardness by Calgon method. Okay. Bye everyone.